my presentation on our lab for Physics 2, charge tapes and the forces acting on/by them. This lab introduced the concept of electric force in a very physical manner. To charge the tapes, we placed two neutral tapes on a desk, one on top of the other, and pulled them apart. This process charged the two pieces of tape, and our goal was to find the charge on the top strip of tape. To determine this, we interacted the top strip with different external objects and with another charged piece of tape. It was important to not handle the charged tapes with our hands too much or allow physical contact with other objects to ensure the charge did not leave the tape and become neutral again. Due to conservation of charge, the tapes ripped apart had an equal magnitude of charge but opposite sign. Therefore, when we made two charged tapes through the same process, the top tapes had the same sign and repelled when we held them next to one another. We then went on to interact the charged tapes with other objects, such as our hand and a charged plastic pen, which we charged through static electricity by rubbing the pen on our hair. We knew from the lab directions that the charged pen was negative, and visually discovered that the charged tape was attracted to the pen. Therefore, the tape must be positively charged. In order to interact with a neutral object, such as our hand, the neutral object's electron clouds shift within the object, based on whether the object is interacting with positively or negatively charged. In this case, the tape attracted to our hand, so we know the electrons in our hand were pulled more towards the charged tape, which therefore created a dipole. So we can expect for the second part of the lab, where we place one charged tape above another, for the tapes to repel and cause the top tape to buckle outward. We will see the diagram of this on the next slide. At this point in the lab, we must consider the force of gravity as well as the electric force. After the top tape repels upward, we can see that the tapes no longer move, which means the net force on the floating tape is 0. The closer the bottom tape is put to the top tape, the stronger the repelling force between the two become. The tapes first start to repel at a distance of 0.05 meters apart. As seen by this computer model, the electric force on the floating tape due to the charged tape below it points upward, while the gravitational force points down. The calculations were also done through this computer program and checked by me by hand. The force of gravity is acceleration, 9.8 meters per second squared, times the mass of the tape, 0.0002 kilograms. Again, the net force must add up to 0 because the top tape is not moving. I calculated the charge on one of the tapes through the assumption that the charges on both of the tapes are exactly the same in magnitude and the charge is uniformly spaced. If the electrons had a positive charge and the protons had a negative charge, the charged tapes would have been negatively instead of positively charged because the electrons would have given the tape on the table a positive charge. Therefore, the tape would not have been attracted to the charged plastic pen, but would have repelled. In conclusion, this lab showed us the general concept of conservation of charge and the interaction of different forces, which led us to deduce on our own the charges of the tapes and be able to predict how they would react with certain objects.